Okay, so this is module 3. You can see there's 3 objectives here. Categorize the various types of computer hardware, demonstrate familiarity with input, output, and maintain hardware components. And I'll just say it again before we start this, make sure you read the chapter. If you read the chapter, ideally read the chapter before this conversation. Hopefully it'll kind of add to it. But this little video here is not a substitute for reading the chapter in order to be prepared for the test, especially when we get to number 3, which is maintaining hardware components. After looking over this, what I'm going to do is I'm going to do the first one in this video, categorizing various types of computer hardware. And then I'm going to do number 2 and number 3 in the next video, because the number 2, as you'll see, is very short, very small, and it'd probably be like a 5-minute video. So I'm going to combine it with 3. So today we're going to look at, or this video, we're going to look at number 1, categorizing various types of computer hardware. Okay, so I think there's 5, 6 different objectives in this one to define each component, obviously. Visually identified. So I'm going to show you some pictures. I don't know how important that is relative to taking the exam, since there's no pictures on the exam, but it's kind of useful to understand what they look like. Talk a little bit about how computers represent data using binary, some benefits of internal, external, and cloud-based storage, which is a decision you'll face, looking at different types of computers, and then just talk for a little bit about when you go to pick a computer, which thing's most important to you, okay? So the first section here is on computer hardware, and I'm gonna go back to that one in a second. So there's really 4 basic pieces that I'm gonna talk about. The CPU, which is kind of referred to in some ways as like the brains of the computer. Maybe the CPU and the memory are the brains of the computer, now that I think about it. The memory, and then what gets information into the computer, which are the input devices, and then what takes the information that's been processed by the computer out, which are output devices. Okay, pretty simple. So just kind of think of that framework as we walk through. So CPU. CPU stands for Central Processing Unit, and like I said, it's kind of the brains. It's what does all of the calculations. And if you remember from last time, we looked at those vacuum tubes and the transistors, and then we looked at integrated circuit chips, and then finally we got to microprocessors. All of those represent all of those kind of tubes that we saw, each one being able to kind of do a 1 or a 0, and it's all of the stuff that's kind of wired in there that gets you a whole computer on a little bitty chip there. So again, if you think back to that picture of that room with all of those various tubes and those people standing there with the wires everywhere, it's all been distilled down to this little chip, which is probably an inch or so by an inch or so. Pretty interesting. Now, data travels in and out of the CPU through something called a bus. And so you can think of it as this chip right here doesn't have anything in it right now. And in order to process, you have to give it some data. So the data goes into the CPU through a bus. And then once it's processed, the output of the processing goes out of the CPU through a bus as well. Okay, so what happens inside of a CPU is something referred to as a machine cycle. And so there's really 2 parts of the CPU. You can see here there's a control unit and the arithmetic logic unit, or ALU, which is responsible for performing the arithmetic operations, which we'll get to in a second, because it's really just taking these things in binary and adding them together in order to create new information or process information that's you're going to output. And it basically through 4 steps there. Fetching, so it's getting information that's coming in a certain form. It's decoding that information. And once it's decoded, it's going to go over to the ALU unit. It's going to execute some type of operation on the data. And then it's going to store the information. And then, as we said before, the information is going to go out. So this is the basic cycle. Think about it in your own brain. You get some information, that's the fetch part, and then you decipher it, like through your eyes. So let's say you're looking at something. So you're fetching it through your eyes, and your eyes decode that, gets into your brain, and your brain does something with that, and then it stores the information. So if you're looking at a tree, it'll come through your eye, and the eye will kind of mess with it a little bit and flip it. Then that information goes into your brain. Your brain sees that as a tree, and then maybe you store that information in the back of your mind. Oh, that's the tree that's in front of my house. So it's a very similar process, analogous to kind of how our brains work, is how the computer CPU works. Okay, so that's the CPU. Next one is memory. Memory is just responsible for holding data as they're being processed by the CPU. And there's really two types of data. And we're going to get to this a little bit more in the input-output pieces, but there's read-only memory and random access memory. Now, what you have to kind of remember about this is read-only memory is memory that never goes away. So if I pulled the plug on your computer and your computer went dead, and I plug it back in, whatever's on that read-only memory is going to be there. There's very little on the read-only memory. There's this BIOS, which is a basic input-output system. There's power on self-test and firmware. So there's real basics. So when you turn a computer on, the computer is looking at the read-only memory. And the read-only memory is what has all the information's on how to start up the program. So the power on self-test is just, sometimes you can hear a little beep. It goes through and looks at all the components of the computer. And every once in a while, you hear like a beep, beep, maybe. That just kind of indicates that everything is good. If something's not good, that's when your computer fails to boot, okay? And there's often specific instructions on the ROM chip, and that's firmware. So this is the stuff that doesn't get erased when your computer gets turned off. It's always there, and it's what the computer uses to boot up the computer. Then you have random access memory, which is RAM. Okay, RAM is stuff that goes away, and usually have a lot more RAM than ROM. So with RAM, you're going to, so for example, when you do something in Microsoft Word or Excel, all of that information is stored in RAM. And that's why if you don't save it, what happens is if someone actually trips over, like you lose power, trips over the cord, or your battery dies, when you turn it back on, it's gone. So it's something that's referred to as volatile, meaning it can change. And virtual memory and page swapping is just ways that the computer uses in order to store data that can't fit on the RAM too. So you have actual RAM. You go buy a computer, that'll be one of the things that you look at. How much RAM? Typically now you're going to have 8 gigabytes of RAM, maybe 16 gigabytes of RAM, which is quite a lot compared to what it used to be. And so if you run out of that RAM, the computer can use other memory within the computer, like on your hard disk, in order to create some virtual memory that they can use to augment it. And then finally, the input-output piece. This should be pretty straightforward. Input devices get stuff into the computer. Output devices displays information that the computer has processed. So just think of it, an easy one is a keyboard. You type on a keyboard, and that information ends up in the computer. The computer processes, like let's say you typed in 2 plus 2, right? And you executed a program that's going to add those two numbers together. You'd put it in with a keyboard, and then the results will be placed on your monitor. That's the output. But there's lots of different input-output devices. You can use a microphone as an input device if you're talking to Siri, for example, on a handheld. A mouse is an input device. A webcam is an input device. And then output, primarily a monitor, but also speakers and printers and other forms as well. Okay, so going back to this concept of RAM right here, there's different types of RAM. And so just want to point out a couple things. One over here, you'll notice volatile and non-volatile. I kind of talked about that before. Volatile just means that it's not stable. So if you know someone who's volatile, they're not stable people usually, okay? And volatile just means in this case, it disappears. So if you lose power, it's gone. Non-volatile means that it stays even if it doesn't have power. So you've probably seen a couple, there's different types of RAM here. So like dynamic RAM or static RAM, both of these are volatile. So you have to constantly have energy applied to it, or what will happen is it will just disappear. Now the static RAM, this just means it gives you a little bit more safety, because if it loses some power, it can maintain it. But of course, you're paying for that. Then here's another one that uses magnetic charges. And again, once the energy is removed, the power is removed, the magnetic flips, and you're back to where it was when it started. And then this flash memory here. So it's, again, less expensive, and it retains a constant in the absence of power. What I think you really need to take away from this is that there's some RAM that's volatile and some RAM that's not volatile, okay? And again, when you go to buy a computer, you're gonna be told how much of this RAM is present. Most of the RAM that you buy with a computer is going to be of the volatile type. Okay, storage devices. This is different than the what we're talking about here. This is the stuff that's on board a computer, you know, the stuff that kind of gets loaded. Storage devices are things that actually you can take with you. Now, there are some, like this internal hard drive that's on a laptop, that stays with the laptop or the desktop when you're using it, okay? Usually they are much, much, much larger, okay? So often you'll buy, you know, 8 gigabytes of RAM, but maybe a terabyte, which is much, much larger, you know, 1,000 gigabyte, than much larger than a RAM, obviously. So you have, and you can also augment those. So if you have, in this one, if you run out of space on this drive, you can buy one of these external hard drives about the size of your phone. You also have flash drives. Lots of people use flash drives. You probably use a flash drive, which again can be, you know, 20 or 30 or 40, 50 gigabytes, pretty large, or these small memory cards, which usually get used in kind of cameras or maybe phones or something else that's a little bit more portable, okay? So these things augment it. So again, this is the type of stuff you might store all your work from a semester on, or my sons use one of these external drives here to store games from their Xbox because they've run out of the internal hard drive space in the Xbox. In fact, one of the things you can buy with the Xbox is you can buy that an 8 gigabyte and you pay a certain amount of money, or you can buy 100 gigabyte and pay more. And very often it's cheaper to buy the internal 8 gigabyte and then just buy an external hard drive too. So a lot of this has to do with what you're doing, how much storage you need, and how much money you want to spend. Okay, so shifting gears a little bit, we're going to talk about the binary system, which is how computers represent data. So the normal number system that we use every single day, you know, that is base 10. And it's called base 10 because there's 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And each of those 10 digits represent a different place. So there's the ones place, the tens place, and the hundreds place. So you can have 100, 200, 300, all the way up to 900. And after that, it goes back to 0, and the 1 moves over to the next one, becomes 1,000, 2,000, 3,000. Well, with a binary system, you only have 2 valid values, a 0 or a 1. And so each of the number places doesn't have a tens place or a hundreds place. It's a place in the order of 2. So the first place right over here in this number is the 2 to the 0, which is the ones. This one here is 2 to the 1, which is a 2. 2 to the 2, which is 4, and 2 to the third, which is 2 times 2 times 2, right, which would be 8, okay? So we have number here, 0, 1, 0, 1. You add it up. How many ones are there? 0. How many twos are there? 1. How many fours are there? 0. How many eights are there? 1. So 8 plus 2 is 10. So if you look over here, a 10 in the decimal system is represented by 1010, 1010, which is here, okay? So everything in a computer is represented by 0, 1, whether or not there's a charge or not, or whether or not a gate is open in terms of a relay or a circuit, whether or not the circuit is open or the circuit is closed. So everything, words, numbers, pictures, everything is reduced down to these zeros or ones. And inside of the computer, a bit, which is just one of these, it can either be a 0 or a 1, and a word in a computer is represented by a byte, which is 8 bits. So this 10110001 is one quote unquote word in a computer, or a byte. And what they do is they use that to translate something. So think of it this way. When you were younger, if you had a secret code, you would represent a letter or a number as a particular code, and then you would use the code to communicate, and then someone would decipher it. So in this case, what they've done, and this is called an ASCII code, is they figured out, so everyone understands, a 0 is represented by this. Now, a 1 is represented by this. Now, you'll notice this doesn't add up. So this is 0, but this is letting you know that this is a number because it's 0011, 0011. So these are digits. But then you can also represent letters. So all of these things are represented by, and actually 0000100 are all 001, all the way through this represent letters or capital letters. And then this one is representing letters, but they're going to be lowercase letters. And then there's a bunch of other symbols like the dot and the, or the period, comma, the colon, things like that. So when the computer reads this, it decodes that to be a 0. It decodes this to be a lowercase m. So this whole system has been set up because computers can only use 0s or 1s. So when you want to type in the word, like my name is Greg, so it'd be G 0100011111, R, we'll go lowercase, 01110010, E, back to lowercase here, 01100001, and also, and so when the computer gets it, it knows that they're coming in 8 groups of 8. So it'll look at the first 8, and then it'll look at the second 8, and then it'll look at the third 8, and it'll interpret it. So when it reads this first 8, it'll say that's the number letter G, that's the letter R, that's the letter E. And so it goes around in a little bit of a circle in order to process it. So think of it this way with this. I press a T here on the keyboard, and that little T triggers some type of connection here, and the computer or the keyboard knows which one of these keys it hit. And that information is then sent into the computer, right? And then the computer takes that information here, and it converts it to the ASCII binary, which is 01010110. Remember, if we look back on this page, actually, I hope this is the same. I haven't checked it, but we'll check it right now. Yes, it is. 010, like that. So that knows it's a T, and then it goes into the computer for processing. Okay, and then once it goes in the computer, it actually shows back up on the screen. So here's your input here. It goes through a process here that involves the CPU and the computer, and then the output comes out here in the version of a T. Okay, so we talked a little bit about this before on the storage. This is a hard drive. These are internal hard drives. There's 2 basic types. There's the magnetic hard drive, which is an older version, and it looks a lot like some type of CD or DVD player here. There's a reader here, and then there's actual medium. And so this spins, and this little reader works almost like a phonograph. It finds places on this disk, and it reads what's there. So it's got moving parts. This is a solid state, so there's no moving parts. So this one here, obviously, or not obviously, is going to be more expensive than this one because this one is much more stable than this one. If you have one of these and you jiggle it and move it, this little thing can skip. This can have problems. I used to have the old iPods a long time ago, had magnetic hard drives in them. And so if you ran with them or did anything, sometimes they would stop working and you have to reset them. Now all of those, including your phones, have these more solid state type drives that the information is just stored in there. So they're more expensive. We talked about external hard drives. Again, something you can augment. If you run out of space on this drive, you can always augment it on this one, or offloads things here for backup, something like that. This is nice because you can take it with you too if you want. So let's say you take it off your computer or your laptop, and then you put it in some type of storage box. The storage box will keep it safe if there's a fire or something, or if you lose your computer. And then this type of storage, which is in the cloud, which is all in, I'm sure everyone has some type of account today that goes to the cloud through Apple iCloud or Google Drive or Microsoft OneDrive through CCBC. This just allows you to take that information off of your computer and store it in the cloud. And of course, that is in some ways the safest place to go because you can get it anywhere. You can get it if you do your homework. We talked a little about this last time. If you do this, if you do it on this, right, on your laptop, and you forget, then you do it on there and you forget, then you show up at school and you don't have any of your work. If you put it on one of these, you might have it with you, and you can plug it into a local computer and get it off. But if you have it in the cloud, all you have to do is go to your cloud account and you can get it. And if you recall, also talked about there's some potential security issues where now all of your information is stored up there, so anybody who can hack into that can get the information. Whereas this is probably the most secure because it's only on one place. So, you have to kind of make a decision how portable you want your data to be, how secure you want your data to be, what works best for you. Okay, so I think probably the last topic, or maybe close to the last topic here, is going to be pros and cons of different computers. So there's a desktop computer, an all-in-one computer, and a mobile device, okay? And let's just talk about each one. So this is the typical one. This is the one that you'd see in the classroom. It's got typically has a monitor and a system unit, sometimes monitor and system unit. System unit is usually called a stack or a tower of some sort, a keyboard and a mouse. Usually tends to be cheaper and a little bit more powerful because they have more space. They're not worrying about making something small, so they can get away with a little bit here. So they can put a little bit more oomph inside of that for your dollar. Also, you can flip this around and get into the back, and you can add different cards or upgrade. It's pretty modular and easy to do, but you have to leave it home. You can't take it with you. All-in-one computers are very similar to desktop computers, except there's usually not one of these. So these are like the ones we have in class. If you go in class, you're just going to see a monitor, a keyboard, and a mouse. You're not going to see the tower. And that's because the tower and all that information is kind of part of the monitor. This is like an older iMac. So the nice thing is, people, look how nice and neat this looks. There's only really one cord that's behind here. That's the cord that brings power. It takes a little less space because you don't have to worry about where to store that tower. Usually, nowadays, they're not upgradable. Once you buy them, that's what it is. You can't add RAM or anything else to them. And if they break, they're probably a little bit more difficult to fix too, and tend to be a little bit more expensive, sometimes for the aesthetics, but also just because, again, your things got to be made smaller in order to get them all in one piece there. Last, if a portable or handheld device, we kind of skipped over more of a laptop, but a laptop is kind of more of, I would say, the portable device. A tablet is very portable, but of course these are not going to be powerful, and you really can't get there and upgrade them. In fact, I consider a lot of the tablet to be just kind of more of a consumption device, for doing email or watching a movie or surfing the web. Not something that I really want to do much work on, because the keyboard is usually virtual, which takes up part of the screen. Although there's a big push from both Microsoft and Apple now to create these kind of dual devices, that are both tablets and still retain all of the power of a laptop. And it's to be determined whether or not that's actually very effective. But some people will prefer it just based on the portability. Or like me, I have two. I have a laptop and I also have a tablet. And I usually carry the tablet with me when I go someplace to be able to get the information. But when I need to do real work, I'm doing it on the laptop. So these are just some questions. So when you go to buy a computer, you need to ask yourself, basically, you're trying to figure out, what do you need? So here's a couple good questions. Do you need it for specific software? So, safe thing about at CCBC, if you buy it here, if you buy it for use at CCBC, you're going to want to be very careful, because a lot of the work, especially in this class, is done on a Windows-based system. So if you buy if you're going to buy a Apple-based system, you might have some trouble. That's the only computer that you have. So a lot of colleges and other businesses really are kind of set on a Microsoft platform. So if you're buying it for those things, you might want to stick with Microsoft, even if you think Apple's cooler. Levels of compatibility, lots of things are generally compatible, but you want to be compatible with other devices. So listen, if you already have an iPhone and an iPad, and then you're looking to buy a computer, you might want to get a MacBook or an iMac, because everything works together. You can put stuff on your phone and it automatically makes it over to the iMac. Now, nowadays, lots of things are built to be compatible, especially if you use web-based applications. Like, so if you're running Google Docs, you can get Google Docs on a portable device, and you can get a Google Docs even on an iMac. So specific hardware to perform tasks, unless you're doing, like if you're doing a lot of video processing or photography or very, very large calculations, you're probably going to want a faster processor and maybe greater RAM. But if you're just doing email or web, like if you're buying a laptop for your grandparents, you can get a pretty basic laptop because all they really want to probably do is do email and some web surfing. What are you going to do? That kind of relates to the previous one. If you're going to be doing a lot of high-end calculations, you're going to probably want a more powerful computer. Where are you going to be using it? It doesn't need to be mobile. You could have a desktop at home and just use the laptops at the library. Just through this little COVID thing, people got themselves in a little bit of trouble. Not people got in trouble, they found themselves in a little bit of trouble because they didn't have access to some of the resources in the library or the resource center. So that might be different now. People might think, well, maybe I do need to get a computer. Maybe it does need to be mobile because I have to move it around, or maybe I prefer desktop. Do I have a place to put it? And then if you get, do you need a hard drive? Do you need like a CD or DVD player? They used to always come with laptops, but nowadays they're not on there. But maybe you want to rip some CDs or rip some movie stuff, or get movie clips or something for some type of video processing. You might want one of those, and that's a peripheral device you have to buy. Some people just take a laptop, but other people, when they get a laptop and they come home, they want to be able to plug into a larger monitor or have an external keyboard, Bluetooth keyboard, or Bluetooth mouse as well. So again, you have to ask all your questions, and because every time you go up in hardware or change platform or add a different device, the cost is going to change. So you have to balance all of that against how much money you have to spend. Processor requirements, talked a little bit about that. Memory requirements, talk about usually, this says computers will list 4 gig, mostly 8 gig are normal. 16 to 32 is really only if you're doing high-end gaming or video processing. And we talk about storage requirements and stuff too. So the net of it, between these things, these are good types of questions to ask when you're going to buy a computer. And you really should look at, again, it says table 3.3, evaluating system requirements. Really look at what you need, because what you need is going to drive what you should get. And if you buy something that you don't need, that's over the top, you're going to spend a lot more money on it.